So I'm here in this room that I'm building, and we've seen the framing of this triangle here. And now we want to use some trigonometry to figure out how much drywall we need to go up this roof line. How long is that roof, that hypotenuse of that triangle? Can we use some trigonometry for it? Some sines, some cosines, some tangents? Well, let's find out. So we're going to want to figure out what this length is here, all right? And we've got this little right triangle we looked at in the last lesson. And so we got to figure out, well, what's this little hypotenuse going on here? So we'll need some dimensions here. Let's get this guy out of there. We can look at the blueprints. We know this is 10 feet. We know that we've got a slope of 5/12 that gave us this angle of 22.6. And so we need to figure out, well, what is this hypotenuse? If this is 10 feet across, that's the width of this room, how long is that hypotenuse? Now, is tangent going to help us? Tangent, remember tangent? Tangent was opposite over adjacent. So tangent's not going to help us because tangent doesn't have anything to do with the hypotenuse. So we need something new, and we're going to call these ratios the sine and the cosine. So remember, trigonometry is the ratio of sides in a right triangle. And when we have a right triangle, something like this, remember we have an angle, which we'll just call A because I don't know the alphabet very high. And this is a right triangle. And we've got the opposite. That's the opposite leg. We've got the adjacent leg that's connected to the angle A. And this is the hypotenuse. All right, the hypotenuse. All right, so we're going to have two new ratios here. We got the sine and the cosine. The sine is going to be the length of the opposite leg to angle A over the length of the hypotenuse, and we're going to call that the sine. The cosine is the length of the leg that's adjacent to angle A. Remember, adjacent means connected over the hypotenuse. These are ratios. So we're going to abbreviate these like this. We'll say the sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Right? So let's see how we can use these. So we have defined these two ratios. We've got the sine, which we abbreviate SIN, a big abbreviation, right? We lost an E, huh? So don't read this as sin. It's not a sin, all right? It's sine. The sine of A is the opposite over the hypotenuse. The cosine, which we abbreviate as COS or cos, don't read as cos. It's cosine of A equals adjacent over hypotenuse. We see the cosine of A, by the way. So, again, we're just talking about right triangles, and we've got these, they relate to A. And this could be any letter you want, but I don't know, stuck on A. So now we got a triangle here. So if we have a triangle, like this 6, 8, 10 triangle, right triangle that is, and we want to find the sine and the cosine. Well, the sine of A, we said, was the opposite over the hypotenuse. All right, sine is opposite over the hypotenuse. So we've got to find angle A here, and we've got to find out which leg is opposite. Well, opposite means go all the way across the triangle there, over there to the 8. So the opposite is the 8. And there we go. 8. The hypotenuse, well, the hypotenuse is 10. That's just the longest side. The hypotenuse is always opposite of the right angle. So here's our right angle, and so the hypotenuse is over here. Usually it's easy to see unless we go turn that around. Now the cosine of angle A is the adjacent over the hypotenuse. So we got to start at angle A and say which leg, there's two legs, which leg is connected to angle A, and that is 6. All right, so we have the adjacent, which is 6, and the hypotenuse, which is 10. Now, by the way, we should simplify this, want to be in this habit. This is really 3/5, and this one is 4/5. All right. Now, if we want the sine of B, well, now we're going to start in a different spot. So now we're starting here at B. So sine is still opposite over hypotenuse, but now it's the sine of B.
So we want to say, well, what is the opposite leg to B? The opposite leg to B is 6. You might say, wait a minute, wait. I thought 6 was adjacent. Well, it was adjacent to angle A, but it is opposite to B. So what is adjacent to A is opposite to B in this triangle. Okay? And so we'll simplify that again. So 6/10, and that is 3/5. Now the cosine of B, we'll go back to our triangle here. Cosine is adjacent over hypotenuse. So cosine is adjacent. So here's our angle B. Which of these two legs is adjacent or connected to angle B? That is 8. So the 8 is our adjacent. So we have cosine of B is 8/10, which is 4/5. All right, now let's see what's going on. Do you notice anything interesting here? We got the sine of B is 3/5. The cosine of B is 4/5. The sine of A is 4/5. And the cosine of A is 3/5. Well, we should notice a little connection here, right? The cosine of A is 3/5. And the sine of B is 3/5. These are the same. And the sine of A is 4/5, which is the cosine of B, which is 4/5. Those are the same. So we've got a little connection here, huh? So the cosine of one is equal to the sine of the other. Okay, so the cosine of A is equal to the sine of B in the same triangle. And if we're talking A and B in the same triangle, then the sine of A is equal to the cosine of B. All right. Now, look at those two angles. What's interesting about those two angles? Angle A and angle B. What do we know about those two angles? They're different. They're different angles. We know they're acute. This guy's 90 degrees, right? So those two are acute angles. And since C is 90 degrees, then these two have to add up to 90. These are complementary. Remember that? Complementary. They complement each other. They say, you're right. No, you're right. No, you're right. No, we're both right. They complement each other. Haha. Okay, so A and B are complementary angles. So that's going to be useful to us, all right? And as we get into later on, down in a pre-calculus class probably, when you're doing some really heavy-duty trigonometry, you'll really get into this some more. But this is just kind of noticing some useful, important things about these. So these are complementary angles. Great. So sine and cosine, they're just ratios very much like tangents. However, they're ratios of different sides. Okay, and so now let's go to our calculator here, and we'll pull out a calculator for this. All right, we have the sine of 15. Let's check out our calculator. And so we've got projector mode. We've got the sine. That's under functions if you're using Desmos. The sine of 15 degrees. Now remember, we got to make sure this is in degrees. If you're using the scientific version of Desmos, it's got this cool little slider right here. If you're using the graphing calculator version of Desmos, then you got to go under the settings, the little tool thing there, all right? But make sure it's in degrees, or if you have a scientific calculator, got to be in degrees. So it's 0.2588, all right? 0.2588. The sine of 15 is 0.2588. Great. So we got that's a big point. 2588. Great. So that's the sine. Let me get a decimal point that works there. All right. Round it off. Now, that 0.25, that's about 25%, or rounded to 26% there. So all that means, remember, sine is the opposite over the hypotenuse. So that means if you were to make a triangle, a right triangle, and you were to have 15 degrees here, then whatever the hypotenuse is here, then this length is going to be 25% of it. So if this is 100, this is going to be about 25, or actually 25.88. Okay, it's just a ratio. So the in a 15-degree triangle, this guy is a, oh, where'd you go? Come back, come back, come back. All right, so this guy is 25%. All right, cool. Well, how about the cosine of 75? Let's check that out. So we've got the cosine. Let's enter there. Cosine of, what you said, 75, right? Whoa, well, that's the same thing. Sine of 15 is the same as a cosine of 75. That's strange. Or is it? So it was 0.2588, right? So 0.2588. Well, what did we just say about the sine and cosine of two angles that are complementary? Well, they're going to be the same. Because if this guy, in this little quick example, if this 15-degree angle has that sine, well, this guy's 75 degrees, right? And so the opposite of the 15 is the adjacent to the 75, all right? The opposite of one is the adjacent of the other, so the cosine of the 15, or the 75, is equal to the sine of 15, okay? Well, lots of different angles. What about the sine of 60? Okay, sine of 60. That one's going to be another interesting decimal. Okay, 60-degree angles are going to be very useful to us. Okay, the cosine of 60 is even more interesting. I'm going to throw that in there. Look, the cosine of 60 is just plain old 0.5. So they're not always irrational numbers like 0.8660 there. All right. Sometimes they're nice, neat fractions. Now, we're going to need this one here in the future, that 22.6, looking ahead, cosine of 22.6. Let's try that again, 2.6, 9232, all right, 9232. So that's telling us that if we have a 22.6-degree angle like that roof we're going to look at, then this guy here, the adjacent, is 92% of the hypotenuse. All right, so that's going to be useful to us. Great. So we see this little connection here, all right, and we're going to see that the sine of an acute angle is equal to the cosine of its complement. All right? Not a huge thing, but something worth pointing out. So in other words, the sine of angle A is equal to the cosine of 90 minus whatever that angle A is. All right? So that's kind of useful. If we know that the sine of 40, I'm going to tell you the sine of 40 is 0.6428. All right, so what does that mean about the cosine of 50? Well, what do you notice about 40 and 50? They're complements. So the cosine of one is the sine of the other. Okay. Well, sine, cosine, tangent, opposite, adjacent, hypotenuse. How do we keep all this straight? Well, let's see. Got a little video for you to help you keep it straight here. Let's see. So one day, I was trying to figure out the height of this tree. Got my calculator out, trying to figure out, should I use sine, cosine, or tangent? Couldn't figure it out, so I did what any sensible person would do, got frustrated, and I kicked the tree. And then what happened? I think I broke my toe, so I had to get a bucket of ice, put my foot in the bucket of ice, and I was sitting there, soaking my toe in the ice, and it came to me. I know what to use, SOHCAHTOA. And as I'm sitting there using SOHCAHTOA, I knew which one to use. There you have it, SOHCAHTOA, all right? So, don't get frustrated. Don't go kicking the tree. You're trying to remember sine, cosine, tangent. You got to remember all these definitions. Well, here's the key. We've got sine is equal to opposite over the hypotenuse. See that? Sine is equal to opposite over hypotenuse. Then we've got, put a comma there. Cosine is equal to adjacent over hypotenuse. All right, cosine is adjacent over hypotenuse. And then you've got your tangent, which is the tangent is equal to opposite over adjacent. SOHCAHTOA. There you have it, all right? Sine, cosine, tangent, SOHCAHTOA, all right? Put a comma there. So a little acronym there that will hopefully help you remember that. All right. Great. Well, let's try using that. So we're going to find some missing sides, kind of like we did with tangent here. And we're going to have some steps. First step here, we want to decide how the given and the missing sides relate to the angle. How do they relate to the angle? All right, so we got to look at the given sides and the missing sides, and how do they relate to that angle? Are they opposite? Are they adjacent? Are they hypotenuse? Then we need to pick a ratio, either sine, cosine, and tangent. And to do that, we're going to be thinking, what was that word again? I kind of forgot. Oh, yeah, that's right. SOHCAHTOA. Okay, SOHCAHTOA. Right, that's right. So, and then we can use, we're going to write our equation using our generic trig ratio. And then we're going to fill in the numbers for whichever, for the angles and the sides there. All right, well, let's try it out. So the directions, find the missing sides using trigonometry here. Well, here we know this angle is 33. So what is this, 5.1? That's the hypotenuse. What is this x leg? X is this leg over here. How does it relate to this 33 angle? It is the opposite. And so we think SOHCAHTOA. And which one is opposite and hypotenuse? Opposite and hypotenuse. Well, there's opposite and adjacent. Cosine has no opposite in it. It has hypotenuse. Sine uses opposite and hypotenuse. That's the one we need. So we're going to use sine. So we know sine of our angle is opposite over hypotenuse. So the angle we have is 33 degrees. The opposite we don't know, and the hypotenuse is 5.1. Okay, now sine of 33, we need a calculator for that. So we'll go to our calculator, and we've got the sine of 33, and that is 0.5446. 5446, well, remember that, 5446. So we've got 0.5446 equals x over 5.1. Great. Well, that can be solved. These are just numbers now. And so we can just multiply both sides by 5.1 and we'll have it, right? Times 5.1 times 5.1. Okay, and so we end up with, let's go check our calculator out. So we have 5.1 times, and we had 0.5446. All right, great. And there's our number, 2.77746. Now, that's actually not the best answer because we rounded off the 0.5446. So we can actually just type sine of 33 times 5.1. And you'll notice here, well, that's pretty darn close. This is a better answer than this one. But if we're trying to send a rocket to the moon or do some fine precision in some calculations, then we need these decimals. But rounding out to 4 decimal places will get us there. So 2.777, all right. And we'll go to 2.8. We'll round our final answer to the nearest tenth. You'll see that in most of the problems we do. That is good. Don't round off to 3. That would be bad news. But check the directions. These directions don't say what to round it to. But there we have it. All right. So this guy is 2.8. We found out. Great. Always double check. Does that make sense? Yeah, if this is 5.1 and that's 2.8, that kind of makes sense. Great. All right. Let's try another one. How about this one? We'll go through our steps again. We look at our two sides here, and we've got to ask how they relate to the angle. This 6 is a leg because it makes the right angle here. Legs make the right angle. This is the adjacent leg, not the adjective, the adjacent. And this x up here, well, that's the hypotenuse because it's opposite the right angle. So we've got adjacent and hypotenuse. So we think, SOHCAHTOA. Which one uses adjacent and hypotenuse? Well, this uses adjacent, but not hypotenuse. This uses hypotenuse, but not adjacent. So we want to use cosine, which is adjacent and hypotenuse. AH there. Great. So we're going to start with cosine of our angle is adjacent over the hypotenuse. That's the definition. So that's the definition there. And now we know some of these. We know the angle in this case is 31, and the adjacent we know is 6, and the hypotenuse we know is x. Okay? Now, I'm going to do this two ways, all right? One way we'll go to the calculator and we'll round off. The other way, I'll show you we don't even need to go to the calculator until the end, all right? Now, this one's a little more challenging because the x is on the bottom. Got to watch out for that. So when the x is on the bottom, it's going to be a good idea to change this into proportion. Then we can think about it as cross multiplying, all right? So what is the cosine of 31? Let's run over here to our calculator. Cosine of 31 is cosine 31 looks like it's 0.8572. We'll round up 0.8572. So 0.8572 gives us 0.8572 over 1 equals 6 over x. Okay, we're going to cross multiply. Now watch what happens here. Okay, I'm going to do a couple steps. We're going to cross multiply because that's something we're familiar with proportions. Whenever we have a proportion, cross multiply. 0.8572x equals 1 times 6, which is obviously just 6. And then we've got to divide both sides by 0.8572. And so we end up with this x equals 6 over 0.8572, or I might even say x over 1. Now notice this. What happened after this step here? We had this proportion, and notice where the 0.8572 is and the x. And notice down here, after we did a couple steps, what happened? They just traded places. Okay, so that's useful. When we have a proportion, you can swap things diagonally because they have the same cross product. So that's going to be a useful thing here, and we'll use that in a moment. I'll show you kind of a quick shortcut, but let's do this. 6 divided by 0.8572. So 6 divided by 0.8572, going on over to our calculator, we have 6 divided by 0.8572. Okay, and we get 6.99995. Let's round that to 1 decimal place. If we round to 1 decimal place, it gets 7.0. Now, and by the way, in this case, we should be writing 7.0. Don't just put 7. I'm going to put that 0.0 showing that, yes, I actually did round it. It's not rounded to 7. It's rounded to this decimal place. So that 0 is important. All right, now let me show you a little bit of a shortcut. Now, notice this 0.8572 there just came from the cosine of 31. So if we remind ourselves here that this cosine of 31 is just a decimal number, so I'm going to rewrite this. Cosine 31 equals 6 over x. So cosine of 31 is a decimal. Okay, I don't need to go find that decimal right now. I got a feeling it's close to 0.8, but I don't need that right now. So this is an alternate way to do this. Now, the x is on the bottom, so that's a little tricky. We could cross multiply, but we just found out that when we cross multiply, we've got this property of proportions, and this works with all proportions. I can trade those two. I can swap them. I like to call this the swap property. I'm going to take cosine of 31, whatever that is, and the x, and they're going to swap places. So we swapped places here. And over here we have x over 1. Well, x over 1 is just x, isn't it? Yeah, of course. So x, got a little highlighter for some reason, x equals 6 divided by the cosine of 31. Now I can go to my calculator and say, well, what is 6 divided by the cosine of 31? So by typing in 6 divided by the cosine of 31, it gives us the answer we want, 0.6998. All right, we don't have to find this decimal. We don't ever need to know that. All we care about is the final answer. So again, 6.998, we'll round that off to 7. Same answer, a little more direct, 7.0. All right, so you don't have to go find this decimal. You don't really need to write it down until then. You never need to write it down. If you remember, the cosine of 31 is just a decimal number. Now, if this is just too much magic is happening, then for now, write this down. Once you kind of get a better feeling for it, we can skip that. Okay, last problem. Last thing. Now, let's go back to this ceiling trigonometry problem here, all right? We want to find the area of this roof, so we can get some drywall. All right, so we got this slanted roof going on here. Okay, and we know it's 20 feet long. It's 10 feet across here. How big is this area up here? All right, so we got to figure out what r is. Well, we can use the cosine of 22.6. And that's going to be 10 over r, because 10 is the adjacent and r is the hypotenuse, right? So now let's use what we've just worked on. And we know we can swap these two. So r over 1 equals 10 over the cosine of 22.6. And so now we can just divide, go to our calculator. And we have 10 divided by the cosine of 22.6. So 10 divided by the cosine of 22.6. And we got 10.83 feet. All right. And if we wanted to convert that into, that's feet and inches, by the way, we could go subtract 10 from that. And then we could multiply that by 12. So that would be, oh, I guess we need the answer divided by times 12. So that'd be about 10 inches, so about 10 feet, 10 inches. All right, so, okay, cool. So 10.8 feet, r is 10.8 feet. Actually, we'll leave it like that is good. And so the area would be 10.8 times 20, because it's 20 feet long, right? So that's going to be, if we double this, that would be 216 square feet approximately. All right, so anyways, that's the idea. There you have it. To use sine, cosine, and tangent, decide what sides you have and what sides you're looking for, choose the right ratio, SOHCAHTOA, and you can find those missing sides. All right. Good luck. Keep it up.